us living on Earth wasn't always the plan. Or was it? I think that's a good intro. Anyway, Earth almost ended before it started. The forgotten planet of Theia. As you can see here, we have Earth, where we live, where all humans and life and everything else lives. And then we have Theia. Theia is basically a small version of Earth, from what has been hypothesized. Again, Earth, where we are. And then, as you can see in that top right little section, that's our moon. Remember that. So we're going to rewind 4.5 billion years ago. That is a lot of years. That is before life, and that is sort of around when our solar system and or universe, I don't know if it's interchangeable, it might be, it might not be. One of the two and both, maybe, were formed 4.5 billion years ago. This is what Earth looked like 4.5 billion years ago. Very different, very uninviting, some might say. This is, wow, sorry, I just got wrapped up in looking at that. It's a crazy picture. This is what Earth looked like at the time, 4.5 billion years ago. It was not livable whatsoever. And it's kind of interesting because what you're seeing in this picture actually ends up being kind of like the core, or that like first mantle, whatever we learned about in school. It's like that first mantle. I forget what it's called, but yes, trust me. Don't. Okay. Now this is our solar system. The big shiny thing on the right is our sun. Then you got a couple planets hovering around, and then those white lines are the rotation that the planets are on. You can also see Jupiter. That's the big planet over to the left. Jupiter has its own crazy story, and we can honestly all thank Jupiter. We got to wait for that because I think it comes up. But the one thing that you'll really notice is there's a ton of debris, which is the little random rocks everywhere. Today we would just call it a meteor or a meteor. However you want to say that word. You know what I mean. The debris is what's very important to us and a big focal point for what we have going on, because this debris was absolutely terrible. When you're talking about 4.5 billion years, time kind of changes. So maybe we'll call it 100 million years. I'm so bad at math. I don't know, but basically if I say like every 1 million years a massive asteroid struck Earth, you're going to be like, all right, that's a million years. Who cares? But that's like really often in the span of 4 billion years, because that's a lot of millions. You know what I'm saying? So just think of it in that shorter time span, that like this is happening often. So when we have this crazy asteroid cluster going on, Earth was getting hit often. I'm not going to put a number on it, but it was often enough to where Earth wouldn't be habitable. Like if we got smacked by one of these today, game over. Like the Earth was pretty often just getting hammered by like a massive asteroid and then taking, 500 million years to bounce back. And it would and then it would bounce back, and then it would just get destroyed again, and then it would bounce back. Like that's how Earth was made. So yeah, think of it like that. Like it was like a world-ending event if there was a world, but there wasn't, because Earth was a fiery hellscape. So that's where we are at this point in time. Now, Jupiter. Jupiter is badass. Jupiter is the reason that Earth exists in the way that we think of it, and the fact that we're alive. Like Jupiter doesn't get nearly enough credit as it should, because essentially what happened was when the Big Bang and shit like that. I don't know, but essentially at the start of our solar system, our universe, there was a shit ton of rocks and stars and just things floating around the universe, right? And then the biggest stars would be where the biggest gravitational pull around stars, and somehow planets would align, and that's how solar systems are made. So at the beginning of our solar system, there were just a shit ton of rocks and our sun. Now, Jupiter at the time was one of the massive rocks. It was huge, and it was very volatile, as scientists like to say, and it was very aggressive, as some others say. So Jupiter was kind of a dick, but it also saved us, because what Jupiter did was it attracted all of the smaller, which were still sometimes bigger than Earth, rocks towards it with its huge gravitational pull. And that allowed for a more uniform and safe solar system. As I said, Jupiter was kind of a dick. It was very aggressive and volatile, but we have it to thank for being alive, if we're thanking someone for that. So this is sad. This is sad Jupiter, because everyone is just thinking, oh, Jupiter. Sorry, it's really good animation by me. Everyone's thinking, oh, Jupiter, you sucked. You were aggressive. Remember when we talked about Earth having a bunch of asteroids hit it? Imagine the opposite happening. Jupiter was just destroying planets, things that were forming, like possible future Earths. Jupiter was like, hell no, I'm coming in, I'm wiping it all out. And that's why it's portrayed as sad here, because we don't like that behavior, because it comes off as destructive. Like, we would be pissed if Earth got, blown up or sucked in by some massive planet. So that's why Jupiter's sad. But 4.5 billion years ago, Jupiter had a 50 times stronger magnetic pull. That's crazy, because its magnetic pull already is super high. It all has to do with how big the planet is. And Jupiter is massive today, and it was even bigger then. It was 2.5 times bigger, close to 3 times. And it had what's called this grand track migration. So it essentially, instead of going in one universal line around the sun, over a few billion years, it would come in and out and collect all of these rocks and planets and future planets and stars even, and it would kind of just circle around and collect them. And the reason it's called the grand track migration is because Jupiter itself would come off of that axis that it's just spinning, and would actually come closer to the sun and then go further from the sun. And so no one knows why that happened, but it's called the grand track migration. And what it did was it cleared up a lot of space for future planets to grow without all of the things that Jupiter had collected along its way. So, oh yeah, and this is just an image, right? So this is today. That's us, Earth. That's Jupiter. Massive, massive planet. And so whatever gravitational pull that we have, which, we have a moon, we have stuff that gravitates around us, like satellites and shit. So imagine Jupiter's. Like, it's a lot more than ours, obviously. Now that's big. Because this is sort of what Jupiter would look like if it were 2 times the size compared to Earth today. Not perfect, because I had to draw it with my finger on my trackpad, so it's not great, but I think that's about 2 times the size, in that range. So look how small Earth looks like. It just looks like it's almost like a little bitch star. Like it's the same as those little stars surrounding it. So Earth wasn't much. And if Jupiter came close to Earth, I should put it, on its grand track migration, gone, cooked, 100%. Like there's no surviving that. We just would have become part of Jupiter. That's what it did. But on its grand track migration, what Jupiter did was it just collected a shit ton of rocks and future planets that could have either hit Earth, taken over for Earth, somehow messed with Earth's being born and growing, and it took all those and absorbed it, and then it just got I don't think I can say the F word. It just got out. It left, and it moved to its somewhat permanent place in our solar system as it shrunk in size. We kind of covered this grand track migration, but essentially this is Jupiter collecting all of that space debris that was a crazy risk to Earth. We covered it. It's just a cool picture. So, Jupiter's low-key the GOAT because without it, Earth wouldn't exist. Happy Jupiter. So we do have Jupiter to thank for Earth growing, and it's called the Grand Track Migration. And that's an awesome trivia question, kind of just sick to know. I personally didn't give a shit about Jupiter for 25 years, and only recently, as I learned this information, was like, damn, Jupiter, kind of based. I like it. I like what it stands for, like the the violence and the aggression. I like it. And I like that it spared us and it gave us the room to grow. So good shit, Jupiter. Like on top of it, great planet. So after Jupiter clutched up, we had Earth. But the question is, it still looks like a hellscape, still terrifying. What's missing? The moon, right? We have a moon. Everyone knows that. So where was the moon 4.5 billion years ago when Earth looked like this? Well, it didn't exist yet. The space debris, you might think, served as a little cluster and became a moon. You'd be wrong. That's not what happened. Earth stopped getting pounded as often, and it started to grow. Like we discussed earlier, Earth was getting pounded. As we discussed earlier, Earth was getting pounded very often in the grand scheme of universal time. Whether it was every million years or every, few million years, it was just getting pounded really hard by rocks and other planets and things like that. The debris that Jupiter didn't scoop up in its grand track migration, Earth was getting pounded by. But now that Jupiter went through the grand track migration, it wasn't getting pounded so often. And it started to grow. But so did some other planets, because Earth wasn't the only one that was spared from Jupiter's wrath. There were some others that weren't named because eventually they would blow up too. So this is a dope scientific thing that kind of ruins my story actually, but it's good to see. The blue dot represents Earth. You can guess what the yellow one represents. Correct. The sun. Now, the black, this one that starts at L4 right there, that black one, it's circling, it's doing its thing, that was Theia. That planet literally could have been Earth. And that collision, whoever came out winning it was going to be the planet that we later inhabited. It was on the same type of arc around the sun. It had the same types of minerals. Some actually say that the planet that hit us, Theia, had water and was the planet that brought water to Earth. Now, that's just a hypothesis. There's really no way to prove it. Maybe there is, not a scientist. But it was definitely a planet that could support life. And so when you see that crash, right, that we just missed it, but it took out like half of Earth. Like, and at this point, Earth was doing okay. Like, that's a lot of Earth to just get taken out. A lot. So, boom, right? Oh, like, and then you see that little red star, and then it turns to blue. Guess what that is? The moon. Is that what that says? No. This says the collision, but that's the moon. So this little star that looks like the moon, it's not the moon yet. It looked more like Earth, and Earth didn't look like that. But that collision was nuts. Like, it hit mad hard. It's probably like half the size of Earth. So again, imagine today if that happened. Everyone would die forever. Gone. Like, the Earth would never come back because it literally like exploded. Half of Earth was just blown up. Your mom's going to die. You know, your grandma's going to die. Everyone's going to die if this happens while we're alive. But luckily, this is 4.5 billion years ago, and there was no life yet. Now, this is a view from from Theia going towards Earth. It's actually the moon, but pretend it's Theia, which actually is the moon. Mental warfare right there. So just imagine it's like approaching Earth, and Earth's doing well. And the one crazy, cool thing from this is what it would look like, scientists said, if a human was observing it, standing on Earth, looking at Theia come in. For about like 4 years, 4 human years for us, we would go out. I guess there only are human years. We would go outside, look into the sky, and just see a massive planet that looked like Earth literally filling up the entire sky. Like, that's what our sky would look like. And we would just see it coming closer and closer and closer until it struck. So I think it would be pretty badass. Like, it would look pretty cool until it sucked. But I appreciate the visuals and the cool vibe that we would get if we saw something like that. Like, definitely if we have some meteor thing and Earth gets pounded again, I'm going to be out there. I'm going to be checking it out because it's going to look cool. I can guarantee it's going to look really cool. It's going to end really poorly for all life. Definitely humans. Very susceptible, very weak beings. But it's going to look so dope. So I'll be out there. I'll be looking at it all the time. Promise. So now, where is Theia now? Well, it's our moon, which we've discussed. Back in this, we can see circle, 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 bang. Now, and then you get that little spread. So that was the rest of Theia, and then it fell into our orbit because we're not super weak. So we're also like Jupiter, where we have an orbit. And then also some of Theia is inside us. Pause. Resume. When it collided, that collision was so strong that it's hypothesized that maybe half of Theia broke off into the solar system and Earth's orbit, and then the other half became part of our core and actually might have left some really important minerals? I don't know, like important shit on Earth that helped life grow, and water could have been one of them. So the big question is, how do we get from this hellhole to this beautiful Earth? And the answer is Theia, likely. It's not 100% proven, but it's like 80% that Theia gave us water, which, as everyone I hope knows, is how life started. So without this near catastrophic collision 4.5 billion years ago, none of us would be here. Thank you for watching. That is the end of my first scientific video. It was way more fun to make than the other ones, and I hope you somewhat enjoyed it and tolerated it. All right. Catch you next time. And I'm going to talk about maybe more about Jupiter. Or I'll do some other shit. I don't know. I'll figure it out. Good stuff.